19, ladies and gentlemen, is having us expand and factor expressions. And so we're using the distributive property, kind of reversing it also. So one way that we talked about this in class was to use these diagrams of area of rectangles, where you have these two things that are getting multiplied. In this case, it's -1/4, and then it's broken up into, like, two different sections inside the length, and the length is -8x plus 12y. So, like, the area of what's inside represents the product of these two things that are getting multiplied. These two being the parts inside the second group that's getting multiplied. So, if you think of it this way, then you can clearly see that the -1/4 and the -8x could get multiplied to find the area of this box, and this box could be found by multiplying 12y times the -1/4. So a quarter of 8 is 2. So a negative times a negative, this would become 2x inside for the first one. This is part A. And a quarter of 12 is 3, but a negative times a positive is -3y. So technically we have this expression that is 2x plus a -3y, or you could write it as 2x minus 3y. Both are correct. So with the next one, we're doing the opposite of that. We're factoring this into two things. So think of it like this: like, you have your rectangle for part B, but you've already found the two areas. Let's say that your two areas were 36a, and since it's a takeaway 16, this is -16. So the question is, like, what number could you pull out that would go into both of these for multiplication of the area? So this is part B. And with 36 and 16, the number that comes to my mind first is 4. That goes into both of them. So I'm gonna factor out a 4 and see what happens. And so on top, what could I have multiplied 36 times 4 to get 36a? Or what could I have multiplied 4 by to get 36a? I'm sorry. So that, to me, I'm going to use a 9 and an 8, because that product equals the area inside. And then the same thing over here. What could I have multiplied 4 by to get -16? That would have been a -4. So that's the way that I think about setting this up. So if I'm coming backwards, my equivalent expression would have been, okay, I'm taking 4, the height here of this rectangle, and I'm going to multiply it by the group of 9a minus 4, because those are the two lengths that I would put together. And it's a -4. You could write it as plus -4, which is the same as 4 times 9a minus 4. They are equivalent, but that would be a factored version of this expression. All right, and so we can do the same thing down here. You can think of it as okay, I've got this really long rectangle, and inside that really long rectangle, I've got these expressions that have been written out. I got -4xy. I've got a -12xz, and I've got a 20xw. And so first of all, let's start with numbers that go into all of these. So 4, 12, 20. 4 goes into all of those, so I'm going to pull out a 4. And then letters that are in each section. X appears in all of them, so I'm going to pull out 4 and X, because it is a part of every one of these right here. And so up here I'm thinking what numbers I can multiply to get what's below. And those numbers would be, I got to make it negative, so -1 would be involved. I already got an X, but I need to involve a Y. Here I got to make it negative with my multiplication, so that's where I'm going to get a -3 from. X is already involved, so I need to add the Z. And then over here, what times 4 is 20? That would be 5. The X is already involved, so I just need to get the W into the situation. So this would be the same as taking the quantity of 4x and multiplying it by the group -1y plus a -3z plus 5w, which is the same as 4x times the quantity -y minus 3z plus 5w. That would be the shortened version. And that's number 1 and number 2.